of lesson 5.2 is adding and subtracting. We have worked to learn how to simplify radicals, which we're still going to be simplifying radicals. You're still going to probably want to have the blue paper next to you, depending on how well you know your radicals. And then we have worked to multiply and divide. Today it's about adding and subtracting, and anything that involves adding and subtracting. So in reality, we'll actually get into some multiplying and dividing, but everything that involves adding and subtracting is under our umbrella today. So a few more properties of radicals. Like radicals, okay, so if I talk about the terminology like radicals, they have the same index and the same radicand. So not only is it, for instance, cube root of x, but it'd have to be cube root of x there. So it's not just cube root and cube root, it has to be cube root of x and cube root of x. In other words, those are the idea of like radicands. They have to be identical. Not just the 3's, but the x's as well.
Oh.
On topic?
Yes. Would you say this is easier than the multiplication?
I kind of think so.
Kind of.
I don't want to say yes and you guys be like, oh my gosh, this is even harder, Mrs. Sargent. But I really kind of think it's not any harder. I think it might be a little easier. But it's also, I have to adjust to the new homework. I'm not 100% familiar with this homework. So.
Well.
Okay, so like radicals, they have the same index, which is the same 3, and they have the same radicand, which is the x.
Right.
Now, here's the big important deal. Only like radicals can be combined with addition and subtraction. So when we talk about you can only add like terms, you can only add like radicals. You can only add an x with an x. You can't add x with y, right?
Well,
same thing here. I can add cube root of x with cube root of x, but I can't add cube root of x with cube root of y. Kind of like multiplying. You can multiply x and y. We can multiply cube root of x and cube root of y, but we can't add them. Okay, that's going to be the big thing. Now, as we look at our first example, we're being asked to do square root of 20 minus square root of 600 minus square root of 125.
Okay, wait, so what if, they can't, because they're not?
Okay, so currently, can I subtract these 3?
No.
No. Square root of 20, square root of 600, they're all square roots, but they have different radicands, so they have different numbers. So because 20, 600, and 125 are different, I can't subtract these. However, we learned how to simplify radicals. So we don't get to stop and say, cannot do this, until we think about, do any of these radicals have a simpler form? So, square root of 20. Is 20 a perfect square? No. But does 20 have a perfect square in it?
yes.
What do we know about 20?
4 times 5.
Okay. So square root of 20, I can think about as 4 times 5. We pick 4 because it is a perfect square. The square root of 4 becomes 2. The square root of 5 stays 5. Or square root of 5. That's old news, yes?
Right.
Yes. That's pretty basic for what we're doing. We've seen a lot more uglier problems than that, so that's pretty basic. Now, keep going. What about 600? Now, always a good question to ask yourself, is 600 a perfect square?
I think it is.
So, 600, you get a decimal on your calculator, right? But, does 600 divide by something on my blue paper?
Yes, 100.
Okay. Divides by 100?
Times 6.
Okay. So when I see anything that involves 100, I'm going to think about dividing by 100. So I'm going to rewrite square root of 600 as 100 times 6. The square root of 100 is?
10.
10. So 10 goes out front. The square root of 6? Square root of 6, it stays in.
In.
Minus square root of 125. Can I take the square root of 125?
No. No.
No, we get a decimal. Or the fact that 125 is between 121 and 144. That doesn't help me. So I want to know 125. Biggest perfect square it divides by. And if you try these, it doesn't divide by 121. It doesn't divide by anything until you get to 25. Okay? You know how to use the calculator and just try the different divisions, right? If it's not an obvious one. So 125 is 25 times 5. The square root of 25 is 5. That's going to go outside. Square root of 5 stays square root of 5. Okay. Now, we've done some simplifying. Now, can I do any addition and subtraction?
Yes.
Yes? What can I put together?
But 2 is 5. And like the
Okay. So right now, I have a 2 square root of 5. And at the end, I have a minus 5 square root of 5. Why can I put those together? Because they are both square root of 5s. So what is 2 square root of 5 minus 5 square root of 5?
-3.
-3 square root of 5. It's just like saying, what is 2x minus 5x? 2x minus 5x is -3x. 2 square root of 5 minus 5 square root of 5 is going to be -3 square root of 5. What about that minus 10 square root of 6?
You just leave it.
Yeah. I can't, that's a different radical. Now we have to carry it down to our answer. Can I go any further?
Nope. No way.
No. I put all the like radicals together that I can, but now I've got a square root of 5, a square root of 6. Your answer will stay. It is possible sometimes that all of the radicals could add together. And it's possible like this one, you'll get some of them to add together, but not all of them. Okay. Questions there?
No.
Okay, let's try B. Square root of 20 minus cube root of 16 plus cube root of 250 minus square root of 5. Can I add and subtract it as is? No. Okay. My recommendation, go through and do all simplifying you can. Square root of 20. What do we know about square root of 20? Didn't we already talk about this? 20 divides by the perfect square of 4. So that is 4 times 5. The square root of 4 is 2. So we have 2 square root of 5. What about the next piece?
You do 8 and 2.
Okay. He's saying I can do 8 and 2. I know he caught it. It's a cube root, yes? So our worlds are colliding. We have square roots and cube roots in the same problem. So just be careful. So for this one, cube root of 16. Is 16 a perfect square? No, but on my paper is an 8. And we can divide by 8. So I have cube root of 8 times 2. What is the cube root of 8? 2. It's the top one on my paper. So it's going to be 2 outside and then times the cube root of 2. It's important you write that cube because when we get to the end, we're going to need to know what I can and can't put together. Okay? Cube root of 250. Is it a perfect square?
No. 25 times 2.
250 is not on my list. It falls between 216 and 343. But start looking. 250 does divide by 216. Divides by 125, right? I trust that you know how to use the calculators at this point. So this is the cube root. 250 is 125 times 2. Cube root of 125 is 5. Cube root of 2 is cube root of 2,
Oh,
so
shoot.
5 cube root of 2. Okay. And then what about this last one?
And it just stays.
Minus square root of 5? 5 is just 5. It's what my brain says, oh, that's prime. It's 5 times 1. That's the only way I can get it. So I know there's no perfect squares. So I'm just going to carry down the minus square root of 5 so I don't forget it. Okay. Did we end up with some like terms?
Yes.
Yeah, we did end up with some like terms after it's all said and done. What can we put together?
The cube root.
Okay, so 2 square root of 5 minus square root of 5. What is that?
Square root of 5.
And here's my question. What's the invisible number in front of square root of 5 here? So 2 square roots of 5 minus 1 square root of 5 leaves me with 1 square root of 5. So I'm going to have a square root of 5. And then the other piece that can go together, minus 2 cube root of 2 plus 5 cube root of 2. Minus 2 plus 5 is going to be
Plus 3.
plus 3
Cube root of 2.
cube root of 2.
Yes.
Okay. Can I go any farther?
No.
No, we got a 5 under 1, we got a 2 under 1, we got a square root, we got a cube root. They're different in all aspects. Okay? So you're going to need to look for the like terms. Okay. Ready to try C?
Yes.
Cube root of 2,000. Well, my paper doesn't go up that high. So I might throw it on my calculator and just double check, make sure it's not a perfect cube. But you get a decimal, right? But if you look at the very bottom here, our biggest perfect cube that I listed was 1,000. Obviously, my list could go stronger. And we know 2,000 is 2 times 1,000, right? So yes, it's a big number, but it's easy. So this is 1,000 times 2. What is the cube root of 1,000?
10.
That's 10. So this is going to be 10 times the cube root of 2. What about the square root of 2?
Yeah, I just leave it.
Keep it.
Leave it.
Okay. So 2 is prime. I can't do anything with it, so it's just plus square root of 2. Cube root of 128. Is 128 on my cube list? No. So look at numbers below 128.
Boom.
What can
Right here,
128
this guy's
divide
got
by?
it. This guy's got 64.
All right.
Okay. 128 can divide by 64. What is 128 divided by 64?
4. Wait.
I'm going to go for 2.
Oh, I thought you meant like 69.
64, or 128 divided by 64 is 2, so 64 times 2. What is the cube root of 64?
4.
There's the 4. Times the cube root of 2. Okay. Can I put anything together?
Yep. The 10 and the 4, which
Okay.
makes it 6.
Got 10 cube root of 2 minus 4 cube root of 2. So 6 cube root of 2, and then
Plus your square root of 2.
plus square root of 2. Okay, guys, those are the basics for adding and subtracting. Always try simplifying the radicals to look and see if any of them become like terms. And often there will be some type of like terms. Okay. You guys have the information you need there. Now, when you start looking at the bottom part, notice I'm throwing in the word multiply, aren't I? Okay. It's multiply
The product.
binomial radical expressions. Here's the deal, though. You'll notice in this multiplication, there's still addition and subtraction, which is why it is falling under today's. We couldn't have multiplied these yesterday with what we were doing because we didn't know how to add and subtract yet officially. So that's why I'm putting them here. Okay? Okay. A, square root of 6, then parentheses, 5 plus square root of 3. What do I do? Do we distribute?
Yeah.
Yeah, this is just like what you've been doing for years, right? There's a square root of 6 out front, and it's going to distribute to the 5 and the square root of 3. So we have to go back and remember all of our multiplying rules now. Okay? We have to pull those together. So, square root of 6 times 5. Okay, square root of 6 times 5. The 5 is not a square root, so it's going to stay outside. So I'm going to have 5 square root of 6 plus, what's square root of 6 times square root of 3? As long as they are both square roots, we can multiply them. Adding is more specific, but as long as they're both square roots, we can multiply them. Square root of 6 times square root of 3 is going to be square root of 18. Okay. Can I add this? I can't add square root of 6 and square root of 18. Should I just stop here and say I'm done?
No,
you
you
simplify the
shouldn't.
18.
Okay. You should always check for any simplifying. Okay? Whether or not these two end up being able to add together or not, I don't think Savas would take this answer regardless. Because there is simplifying that can be done. They're going to want you to simplify. So, let's see. Square root of 6. Can I do anything with square root of 6? No, it can only multiply 2 times 3 is all it can multiply to be 6. So that isn't helping. So 5 square root of 6, I'm just going to carry down because I'm looking ahead. Square root of 18. Is there a perfect square in 18?
9.
18 divides by 9, right? So 18 is 9 times 2.
3.
And we know the square root of 9 is 3. So this is going to be 3 square root of 2. We also had a 5 square root of 6. What's 5 square root of 6 plus 3 square root of 2? This, right?
Yeah.
It's 5 square root of 6 plus 3 square root of 2. Okay? As I said, I highly doubt, so it ended up not being able to add, right? I highly doubt Savas would let you leave it as 5 square root of 6 plus square root of 18 because it's not simplified. And they're always going to want it in some simplified form. Okay? So just be aware there. Okay. So B, what am I doing again on B?
Same thing.
We are distributing. So, we're going to take this cube root of 7. We're going to distribute. Cube root of 7 times 2. 2 on the outside. And then times cube root of 7. Minus cube root of 7 times cube root of 49.
Cube root of 343.
343, is that what it is? Okay. Cube root of 343. Okay, we've distributed. Can I subtract?
No, but you have a perfect cube.
I can't subtract, but we checked simplifying. Cube root of 7. Can I do anything with cube root of 7?
No.
No. It's smaller than my smallest perfect cube. So that's going to say 2 cube root of 7. What about 343?
Oh, no.
It's on my list, isn't it?
Yeah.
Or I can plug it into my calculator. My calculator will tell it.
6.
Cube root of 343 is
6.
7.
He said,
Can I subtract?
Yes. Wait. Oh no, you can't. I missed that.
Okay. One's a just whole number. The other has a cube root of 7. In order to subtract them, they'd have to both be cube root of 7s. So we're stopping there. Okay. C.
Booyah. This guy got it right here.
he's got it.
What are you going to tell me to do here, Landon?
We're going to distribute. And,
That's
do I go ahead and tell you what I have?
Well, I don't want an answer.
Landon's just wants to let everybody know that he's done with the notes.
I am done.
Okay.
X
So
squared.
we're going to distribute. What are we distributing here?
The x to the x and then square root of 10, and then the negative square root of 10 to the x and then positive square root of 10.
Okay. So you're distributing not once, but you're distributing twice. Some of you might be, I heard the word FOIL out there. Distribute, FOIL. I don't care what you think. Okay. If you say distribute, realize you're distributing twice. If you say FOIL, that's our shortcut. So x times x is
X squared.
x to the second. Remember when you multiply, you add the exponents. What about x times the square root of 10?
X on the front.
I would say x times the square root of 10 is what I would write. You occasionally might see the x at the end, so like square root of 10 times x, but usually I feel like you see it out front. Then we're going to distribute the negative square root of 10. So what's negative square root of 10 times x?
Negative x.
Negative x, square root of 10,
Booyah.
and then
Then you
negative square root of 10 times positive square root of 10.
should be negative
Negative.
square root of 100.
Negative square root of 100.
This way.
Okay.
The middle
So distribute, FOIL, clean it up. With any FOIL type problem, you clean it up. What do we have here?
middle ones cancel.
X square root of 10 minus x square root of 10. Those are going to cancel out. I'm still going to have x squared minus, can I do anything with square root of 100?
Yeah, you can do that.
I hope so. Square root of 100 is
And
10. Now, leading up to when we look at a little bit of division on the backside, notice my middle terms canceled out here, right? We went from a problem that we multiplied that had radicals to an answer that has no radicals, no square roots. Okay, so a vocabulary word that we're going to talk about on the back. This is an example where the two pieces we multiplied together are what we call conjugates. Okay, they are conjugates because they have the same pieces but opposite signs. So because one parenthesis has plus and one parenthesis has minus, they're what we call conjugates. Okay, so I just want to point that vocabulary out there because it's on the back of your paper. We're going to talk about it here coming up soon. And then we kind of went the long way here. Square root of 10 times square root of 10. What could you have shortcutted and done here? Square root of 10 times itself is just itself without the radical. So you could have automatically said, oh, square root of 10 times square root of 10, that's just going to be 10. That is okay as well. Okay. D.
I got you. Right here.
What are we doing?
Distributing.
Distributing again, yes?
Distributing
What's my first distribute?
I don't got shit.
2x and 2x.
Okay. 2x times 2x.
4x squared.
Good. 4x squared. 2x times minus square root of 3.
Negative 2x squared.
Okay. So positive times negative is negative. I'm going to put the 2x out front,
You can do
the square root of 3 out back. Now I'm going to
Same thing.
minus square root of 3 times 2x. Minus times plus is going to be a minus. 2x out front, square root of 3 out back. And minus square root of 3 times minus square root of 3.
Plus 3. 9.
Negative times negative is positive.
Plus 3.
We can go straight to plus 3 if we want, because square root of 3 times square root of 3 is going to be 3. You are also welcome to still say square root of 9 and then go to 3. It doesn't matter to me either way. Okay? But the better, the better we get at this, square root of 3 times square root of 3, it is just 3. That is good to be able to just go straight there. Okay. Can I do anything?
Yeah.
Yeah. Combine the middle guys.
Okay. Notice this time it's not cancel the middle guys, it's
Sure.
combine them, put them together.
Yeah.
Okay. The difference this time, these aren't conjugates because I had the same signs. So my middle terms aren't going to cancel out. So negative 2x square root of 3 minus 2x square root of 3 is going to be minus 4x square root of 3. They're like terms because they both have x's and they both have square root of 3's. Negative 2x minus 2x minus 4x. What about the 4x squared out front? It's just 4x squared. This plus 9 was a
3.
plus 3.
Booyah.
That's it? I can't do anything else?
No.
Okay. I've got a 4x squared. No other x squareds. I got an x and a square root. None of those. I've got a 3. Okay. I'm asking just to keep you guys on your toes. Okay? I don't want you to fall into the false sense of, okay, it's done now. We combine this. We're done. Are we on time? Okay. We're moving a little quicker through these notes than I expected, so I'm trying to, I thought we'd have this next part to do tomorrow, but
We can do it tomorrow.
Yeah. I started
I don't want to rush through it and not know what I'm doing.
That's facts.
That's. And you claim.
Then I can start
She's
the
got
homework
it.
and do the.
And you
Wait,
plan
how much
for it
is on
because,
it?
So.
We
Oh
can
yeah, there's
start
only
the
3. We
homework
should just
right
save
now.
them.
Get the ones done that we know.
okay, here's what I'm going to say then. If I pause here and stop for tomorrow,
We'll do it later.
okay, then what you have just under 10 minutes. I want you in Savas doing the ones you can. Now, listen, here's what I'm going to say. Get in Savas, do the ones you can. There's going to be plenty you can work on that don't involve, notice the back is fractions, right? Anything that's a fraction, skip. Tomorrow, we'll do our back 3 examples, and then you'll probably have some more work time tomorrow,
Finish
Finish
the
them.
homework.
okay?
Sounds
Now,
good.
if you're behind in any Savases, there's 6 of you that have a Savas due today yet, so that's something you can work on.